Okay. All right. Hi everyone. So today we're presenting our final project. Our project is basically about earnings cost transcription and specifically whether the language executives use on these calls can help predict short horizon stock momentums and whether that added anything on top of the standard earnings price signals. So every quarter, public companies hold earning calls. Investors already react heavily to EPS surprise. Basically, that's whether the company beat or meets what analysts were expecting. And that number moves stocks almost immediately. But there's the thing. The actual cost lasts 30 to 60 minutes. Executives talks about forward guidance, demand trends, margin pressures, and competitive dynamics. And then there's a full Q&A with analysts. So that's basically a lot of quantitative information that might continue moving the stock over the next few days. So our research question is, can a deep learning model use earning cost text improve stock direction prediction beyond what the EPS price alone tells us? And we have two horizons for 1 day and 5 day post earnings returns. And our data set has 13,981 earning cost transcription from 2,201 unique companies covering late 2017 through early 2023. The inputs are the transcripts test plus five EPS features, the analyst estimate, the actual report EPS, the surprise percentage, and a flag for whether EPS data is available at all. And about 96% of calls have it. And the labels are binary. So it's about whether was the stock up the next trading day? Was it up after 5 trading days? And more importantly, these labels are nearly 50-50 balance. So getting 50% accuracy is no better than random guessing. That's why we use AUC, the area under the ROC curve, as our primary metric. AUC measures whether the model correctly ranks positive examples above negative ones, regardless of what threshold we pick. We also use a time-based training validation test split to prevent future data from leaking to training. Before I get to the model, let me explain a key challenge. So Standard BERT and ThinBERT are limited to 512 tokens, and that's roughly the first 380 words of a call. And 380 of calls is typically nothing because typically earning calls run 6,000 to 12,000 words. And for the first 512 tokens, it's just usually the operator introduction and legal disclaimer. And the good stuff, which is forward guidance, demand commentary, analyst Q&A, all comes later. So if you naively turn cut to 512 tokens, you are throwing away most of the signals. That's why we use a chunking approach. We split each transcript into up to five overlapping videos of 256 tokens with a stride of 192, covering about more than 1,800 tokens per call. And we learn which chunks matter the most.
So here's our model architecture. First, we split each earning call transcript into up to 8 overlapping chunks because the transcripts are much longer than what ThinBERT can read at once. Each chunk goes through ThinBERT, which is a BERT model pre-trained on financial text. And then we take the CLS embedding to represent that chunk. Then we use the chunk attention layer to combine chunk embeddings. So instead of treating every parts of the transcript equally, the model learns what sections are more important. And after that, we combine the transcript representation with the 5 EPS related feature and feed everything into a small MLP classifier that predicts the probability of stock going up. And for training, we use ADAM-W, dropout, weight decay, and early stopping. So the main ideas here are financial domain pre-training with ThinBERT, long document chunking, attention over transcript sections, and combining text feature with structured EPS data. Next page, please. So we have compared 5 different model setups. starting from simple baseline and gradually adding more complexity. At first, we use an EPS-only logistic regression model with no transcript text. Then we test frozen Finbert using only the first 512 tokens. And after that, we add our chunk attention approach for longer transcripts. Then we combine chunk attention with the EPS features. And finally, our best model is the fully fine-tuned Finbert with chunk attention and EPS fusion. It is shown with the star on the slides. And we have also evaluated our model separately on both the 1-day and 5-day prediction tags. So this slide shows the main AUC results. For the 1-day horizon, the EPS only baseline actually performed the best with an AUC around 0.63. Our fine-tuned model gets very close. It's around 0.625, while the frozen model performed the worst. And for the 5-day horizon, the fine-tuned model performed the best with an AUC about 0.588, beating both the EPS only baseline and the frozen model. So the takeaway is pretty clear here. For median market reactions, the EPS surprise already explains a lot, but over a slightly longer, the 5-day horizons, the transcript language provides additional useful information. We also can consistently see that the fine-tuning performs better than the phrasing, the encoder, which suggests adapting Finbert to this specific task is important.
So a field diagnostic worth mentioning. Training loss stayed near 0.69 throughout, which is the baseline for a balanced binary classification task. That's not a failure. It's expected when you are predicting noisy short horizon returns, and the signal is like real, but it's pretty weak. We also ran threshold calibration, searching threshold from 0.2 to 0.8 on the validation set to maximize F1, then applying chosen threshold once on the test set. The threshold 0.47, the 1-day model gets F1 of 0.68, but the balanced accuracy is only 0.51 because the tuned threshold predicts almost every example as positive. Recall jumps to 99%, which inflates F1, but the model isn't generating classifying. It's mostly predicting up for everything. And that's why we use AUC as the primary metric. It evaluates ranking from raw probability and doesn't change when you shift the threshold. And now we have an example of how the model really works in practice. For the company Markel Corporation, the ticker is MKL, and on the end of 2022, the 1-day model assigned a probability of 0.559 for an upward move, and the actual outcome was up. So this is a correct prediction. The EPS context show a solid beat. Actual EPS of 21 versus analyst estimate of 13. It's about a 57 positive surprise, and that's very credible for an insurance and investment holding company. And the top attended transcript chunk, which is in the middle of the slide, discuss Markel Ventures setting new records in revenue and profitability, despite supply chain challenges and inflationary pressures, which aligns with the positive tune. And one thing to notice here, attention weights across the 8 chunks were nearly uniform, each around 0.125. So the top chunk tells you what the tax model has access to, not it made a sharp casual decision based on that expert. Next page. So finally, the limitation is the predictive signal is modest. We use raw up and down labels rather than sector adjusted abnormal returns. So some movements may reflect market-wide news rather than the call itself. We are also missing potentially important signal like revenue surprise and guidance revisions. The EPS data sourced from public APIs may also contain quality issue for small cap stocks that underwent reverse split or foreign ADRs with currency mismatch. And we flag this in our report as a known limitation. And the attention mechanism gave us a qualitative explanation, not casual ones. And the takeaway is that Finbert chunk attention handles long document problem well. EPS Fusion provides a strong financial anchor. Full fine-tuning improves over frozen representations, and the clearest value from the text-based deep learning is for 5-day horizon, where transcript language provide the modest but measurable delay market signal. Thank you. And any question?
Yes, so why is a fine-tuned model trained on only 2 epochs?
It's because Feinberg is already pre-trained on financial text. We only need light task specific fine-tuning. And with the relative small data set and the large model, more epochs could easily overfit. And that's why we use validation loss and early stopping to select the best checkpoint. Is that it?
Yep.
So thank you guys.